Today we've got super awesome Ander, who's a developer here at Dojo Five, but is so much more than that. I'll let him introduce himself. I'll introduce myself real quick. I'm Joe Schneider. I'm president and founder at Dojo Five, and excited to talk about HIL today. And Ander, why don't you introduce yourself?
Yeah, I'm Dr. Ander Galisteo, and I can only use the PhD to introduce myself, so I'm gonna do it. I have been working at D5 for 1.5 years, almost 1.5 years now. I'm a staff firmware engineer, and yeah, Hardware in the Loop is like a really exciting topic for me. So thanks everyone for joining in, and yeah, maybe we can start now.
Yeah, let's go for it.
Yeah, the first thing to mention is that this webinar is the second in a series of webinars on basically how to modernize your embedded development. Last week, we talked about DevOps with Brandon. I think it was really interesting. There were some concepts that we are going to cover on this presentation related to hardware in the loop. But if you hadn't seen it, probably not now, but if you are watching the recording of this, you can pause it and go to the previous presentation, because I think that it adds a lot of value to what we are going to say today. And yeah, the first question here is, what is hardware in the loop, right? And we had a lot of internal debate trying to figure this out, because we saw that it doesn't have a unique answer. It depends a lot on the project, on the company that is using it, on the requirements, and on the developers too. So what we could figure out was that it has some hardware on it, and it's in a loop somehow. So you are using to basically test something, or to verify something, and you want to do it on actual hardware, and it's on your development loop, but that's it, because that's all the common ground that we have from all the projects that we have seen and worked on.
Yeah, I mean, so and my job here is going to be mostly the razzer of Ander here, because Ander is super smart and he knows all of this stuff very well. But I'm here to make this entertaining a little bit. So tell me, okay, hardware in the loop. It's a hardware in a loop. Like a loop of what? What is this loop? What's important about the loop that makes it hardware in the loop?
So it should be your development loop somehow, or something that it's automatized. It depends a lot on, and we are going to see that later on how you implement hardware in the loop on your project and why you use hardware in the loop on your project. But the idea is that you want to test what you are doing or verify what you are doing on the real thing, and then you want to automatize that somehow. So basically you place your hardware in some automatized setup that you call the loop, and that's it. And yeah, we will see examples later on what this means, but it's very, very specific to each project. And that's probably the first thing that you want to check when talking about hardware in the loop and where to start. First of all, we have received some pre-webinar feedback with some questions, and we are going to explicitly answer them at the end of the presentation, so that everyone has the same common ground for it. Okay.
Yeah. But thank you, by the way, for everybody who brought that up. And by the way, if you have questions as we're going here, please feel free to toss them into the chat. We'll be monitoring them and slide them in where they make sense, or get to them at the end. So be great.
Yeah, exactly. So one of the questions, and we will see that later on too, but was how to start on hardware in the loop or something like that. So probably the best thing that you can do, and the first thing that you need to do, is to step back a little bit and try to understand your project as a whole, and how hardware in the loop is going to fit in your project. Is it going to be a tool that you are going to use for something in particular, or is it going to be the centerpiece of the whole project? Because there are some projects that are more about developing something new. There are other projects where basically you want to verify against some rules, or some agency that wants to verify your system. So You need to see that. Also, it depends a lot on the hardware that you are going to use. How familiar are you with it? How many times have you worked on similar projects? How much money you have to spend it? Because usually hardware in the loop is not something super easy to implement and super cheap to implement. Usually you need to spend a little bit of time and money in order to make it work. So yeah, taking a step back and trying to understand how it fits you, and that's probably the first thing that you want to do with a hardware in the loop setup. Okay, and before continuing, I think it's important to understand that this kind of setup, it's better understand when you are doing modern embedded development, and each one has a different definition of modern, but in my particular case, I believe that the more things the infrastructure does for you while developing, the more modern your setup is. So in the past, when we were basically developing embedded systems, we had to develop them, document them, testing them, making sure that they do what they were supposed to do, so verifying them. And something that I think it's the most painful thing in the world is to retro verify them. So basically, you are working on a feature, you make sure that the feature is working, but you also need to make sure that your feature doesn't break anything else. So you need to test not only your stuff, but all the stuff that has been done before. And if you are able to push that into the infrastructure and allow the infrastructure to do that for you automatically, you can spend more time actually developing. And I think that the development process is much more efficient. And that's at least how I envision it. So this is a very silly example, but it kind of shows how hardware testing can increase exponentially while the project's complexity increases linearly, right? So you have in your embedded system like 3 state machines with 5 stages each. Then you have some peripherals with basically 2 levels and a CAN interface with 10 possible messages. Then you need to test for 7,250 scenarios to test absolutely everything. Most of the times you don't have the capacity to test everything, so you will take a subset of this. But ideally, in order to make sure that everything is working, you want to test the whole possible use case space. And in order to do that, you need to test the 7,250 stages. And if each one takes you around 2 minutes, and that's really optimistic because when you are working with peripherals, then the peripheral, doesn't work correctly, or you need to make sure that you have configured the interface correctly, and it takes way longer. But if it takes just 2 minutes, then you have 12.5 days of an engineer just working to test this. And it can get really, really painful, really, really fast. Testing one feature at a time, that's more or less okay. Testing absolutely everything, it could be a nightmare. And depending on how fast you need this to roll out, that could be crucial for your product or your updates, especially for updates. And we will talk about that later on too. So being able to automatize this somehow and making sure that you are able to, have predictable testing times and the same setup for every developer, I think it's really useful. And that's why we have hardware in the loop. This in systems where we are going to have heavy testing could be really useful because it's faster than any human can be. Doesn't require to actually have a person working there, which makes it cheaper in the majority of times if you use it in the long term. It can work at any hour. So basically you can be, the hardware in the loop setup can be working 24/7 non-stop for weeks if necessary. And yeah, it's constant over time. So depending on your setup, maybe an engineer leaves the company and then someone new needs to come in and they don't know how to test it, but they are the ones responsible for testing it, and it may take longer. So having something that not relying only on the person that is doing the test it's quite useful. And this is usually what people see and what attracts them to hardware in the loop setups. But I think there are some like hidden benefits too that I think that are super interesting. When you have a patch and you have seen that there is some kind of issue with your hardware, it could be a bug, but it may be a vulnerability, a security vulnerability. You see that one of the libraries that you are using has some kind of flaw. Then having a release as soon as possible is really critical. And knowing when the release is going to come out, that's very, very useful. So if you are able to know exactly when the tests are going to end, that's like real value that you add to your system. It also depends on how each developer does things. I heard a couple of times that the best code is the code that doesn't require any documentation. I usually prefer to have some extra documentation to try to fully understand what's going on. Unit tests are really good also to understand how to interact with the code. And hardware in the loop tests are really useful too, because basically they tell you how it is expected, what behavior do you expect from your hardware, and how you are supposed to interact with the hardware itself. So I think that's really, really cool and really useful. And it eliminates the user bias. So each person can do it in a different way. Maybe the tests are not fully correct because of that, but if you have an automated setup, then because no person is involved, you eliminate that fully.
So,
and yeah.
I was let's look to that next slide, because I was just going to break it up a little bit and say, like, okay, so why wouldn't I just test everything with HIL? And then of course you flip up the slide and this is, everything, why you wouldn't just test everything with HIL. But yeah, how do I maybe go through the slide and then we should have that discussion?
Yeah. So I have seen like a lot of people having this like philosophical debate. Should I unit test? Should I use HIL?
Yeah.
I don't know exactly what it works best for my setup. And I don't think they are not mutually exclusive, right? You can have both on your system. But in my mind, it's very hard to justify not having unit tests because they are so useful, so easy to implement. They don't require too much, right? Too much effort.
This is a perfect setup. This is a perfect setup because, so we're all about modernizing embedded, right? And many of the embedded environments that I've seen, that I've been in, for some reason, like look at this chart. Like HIL has red X's in 3 of the 4 categories you've called out. Like it's kind of a bad choice for a lot of reasons. But everybody does that. Like you walk into most embedded shops, non-modern embedded shops, and they will say, "Oh yeah, I heard about it. Unit tests. I don't really know. Like they seem like a lot of work. I didn't do them, but check out this cool HIL setup." Or like this is. And then I'm like, "How do you test this? How do you what is like releasing to production look like?" And they're like, well, we kind of have a testing document and it's manual, and I throw it over the wall to the QA guys, and and then like. I mean, they yell at me because I'm always throwing it over to them like one day before the release, and they've told me 10 times that it takes like 3 days to run this test plan. And they missed a couple of things the last release. I mean, like that is state of the art in a lot of embedded companies. It's like, why are we doing that over and over again? This is the worst choice for a lot of reasons. But there's something about HIL that does provide value, right? I mean, so like why? I mean, part of modernizing is a lot of us saying like, stop doing that stuff and automate the majority of your tests in unit tests. So then and we want to get people to use that. So then when does it make sense to use HIL, and when should you use unit tests instead? And please do both, by the way, to everyone listening.
Again, they are not mutually exclusive. In my opinion, not having unit tests, I mean, I haven't seen a project where not having unit tests was a benefit. I haven't seen it. I don't know any example of that. Maybe someone in chat can say, yeah, I had a project where unit tests, didn't make any sense. But it's so easy to implement. You can do it basically in any computer. You don't require the actual hardware to do it. So the price it's way cheaper to implement too, and faster. So it just makes sense. And usually you unit test like units of code. That's why it's called unit tests, right? And that's really useful to see how the logic is. But I was talking with my partner before this presentation. She's not an engineer, so I was like explaining her how all this was working. And one example that I came up with was like, this is like, so bear with me here. This is a little bit like the stock market. Okay, you can do all the math that you want in your head. You can like try to plan all your algorithms and how it's going to work and where you are going to invest. But the real test is when you actually put money on it, right? And then you see if it's working or if it's not working. And this is the same thing. No matter how many unit tests you have, no matter how many theoretical things you do, until you test your system on the real hardware, you are not 100% confident that it's going to work on hardware, right? Because this is the real deal. For example, if you are on a project that it's just a prototype that you are going to use to show to some, I don't know, to some higher management or to a funding agency, whatever, probably you don't want to use hardware in the loop because you are going to be short on budget probably and short on time. And probably the prototype is going to change a lot. Maybe you change the whole system. So like creating a hardware in the loop setup to test everything and to verify everything probably doesn't make any sense. But if your system is very heavy on specifications and you need to show to a third party that your system is working and that you fulfill all their specifications and you are going to build and to spend a huge amount of resources on like making this work, probably it makes sense to have hardware in the loop setup. It also depends. Yeah.
What I hear you saying there, and so I'll just break it up again, is that like a lot of this testing, because you laid out the problem earlier that, hey, like in any significantly complex system, of which embedded systems like almost instantly become, you will have billions, trillions, like of states that this thing could possibly be in very quickly. And so you can't test everything. So there's this idea of like risk-based testing, right? It's like, and this is very familiar to folks in the medical field as well, where the FDA recommends a lot of like risk-based management of the entire project and the product. And I think testing has maybe come at the same conclusion, but from a different angle. And I think this is a place too where engineers get stuck, especially embedded engineers. No formal training maybe in testing. They're kind of slapping some tools together. Like I think we should probably have this thing wired up or whatever. But like there's no how do I use a risk-based approach to determine how I should test?
I was going to mention something similar later on, but I can do it right now. I believe that developing is a little bit more mechanical, right? You just add things. Testing, it's, for me at least, it's purely art. It's an art form. Knowing exactly, because at the end of the day, when you have a system that has too many stages, you cannot test all of them. It will take like the universe will die from heat death before you are able to test absolutely everything. So you need to take a subset, and knowing which subset of tests like are representative of your system, that's a form of art, in my opinion. And both unit tests and hardware in the loop suffer from this. Yeah. Because you cannot make sure that it doesn't matter how many unit tests you do, you can never be sure that the function is going to work 100% of the time, all the time, and
that's a key point. Like none of this testing guarantees that your device is bug free, right? And I think it's very difficult to do that. But you can focus on the main use cases, focus on the secondary use cases, focus on the error cases, and then I think really when you're considering like this unit test versus HIL test, like I like to use the analogy of a car sometimes, right? If I think about the pieces that go into a car, you've got I don't know, and I'm not a car expert, so my apologies to everyone but you've got an alternator, you've got an engine, you've got a fuel tank, you've got a brake light. Each of these things need to work in isolation if you have any hope of the car to work as a whole, right? So it makes sense to understand like what what is the job of those pieces, those components in isolation, and then test those pieces and make sure they do their job. This is somewhat like black box testing of the components, where we don't care if the light bulb's made out of, I don't know, tungsten or magnesium, or I don't know, like a million different, I don't know anything about light bulbs either, by the way, but who cares? When I apply voltage to it, it needs to light up. And maybe it's an LED, or I'm sure they are at this point, or most cars are. So it's like, I don't really care how it does it. Just does it do the job it needs to? And then, but here's the twist. When I test a light bulb in like kind of component or a module level test, and I apply voltage, it doesn't light up, I know exactly where the problem's at. It's the light bulb. Okay. If instead I'm using only HIL, I use a slightly different analogy. If I get in the car and I turn on the gas, or I get in the car and I turn on the car and I hit the gas and nothing happens. In my mind, that's like a HIL test. So really good, first off, that we caught that issue, because obviously all of our users, they're expecting to be able to hit the gas and go in a car. But at this point, I don't know where the issue is, but at least I know there's an issue. So that's where I kind of see a spectrum here of like, HIL on one end, where like it will tell me if I've got, product level, requirements level issues with the whole system, but it's not very good at telling me where the problem is, versus unit test, where it's really good at telling me if there's an issue in individual components, but it's like the individual components could be wired together incorrectly, or maybe the design of the components is such that together, like each individually they look great, but together they don't make the car drive. And that's where I think there's this spectrum of like really focusing on what are you testing, and focusing HIL in on the tests that are testing the system level behavior. And because it's very tempting to do like you mentioned earlier with like something that runs on CAN, right? Like, well, let's test that the CAN thing works, in a HIL test, and that could be very expensive, very time consuming, and likely a lot of the bugs that you're going to find could also be tested in unit tests, and you'll know exactly where they are, and you'll find them faster and sooner and cheaper, versus a HIL test focusing on the system level testing.
Yeah, I mean, for me, it's like unit test is focusing more on something specific of your system, and hardware in the loop usually verifies the system as a whole, which is basically what you said, but without cars in the example. Okay.
Nice. Yeah. No, it's really interesting, because I think this is going to be important. So we had the poll go out, and really great. Thank you everybody who filled out the poll in Zoom. And it looks like over 75% of the folks have either no experience with HIL or are just aware of HIL, but they haven't actually used HIL. They haven't actually built a HIL. 15% of our attendees here have built a HIL, which is interesting. And so like the majority of folks are not in this like kind of automated hardware in the loop setup. So it's kind of like, if maybe they're not using unit tests either. And how can we like, it's just, I'm interested to help these folks learn about how to approach this.
I don't know who's on the chat, but if there is any embedded developer, I'm pretty sure they have used HIL even if they didn't realize it. Like if
85% are developers. 85% are developers.
That's good. Then I assume that at some point you have automatized something and you have run tests on hardware, right? Well, technically that's hardware in the loop too. Maybe it's not very fancy, but you have kind of interact with it. So yeah, I think that embedded developers, we are usually lazy. So we will try to automatize things even if we don't realize it too much. So probably
I prefer to call it like, skill.
Yeah, exactly. Skill. Yeah, that sounds better. I'm not really good at marketing. That's why. But yeah, usually when you have to automatize something on your setup, it could be like some really small tests that you do, or it could be some verification thing that you do. Even if it's really small, probably that's your first step into hardware in the loop. And how to start with this? Probably the best thing would be to start with unit tests, because again, it's easier. And then you can start building your mindset around how to make it modern, how to test the stuff automatically, And then once that you have a project that has the budget for it and basically you have the time to implement it, probably will be good to have some minimal version of hardware in the loop that we will talk about later on. Yeah, to start seeing how it fits you.
Because there are ways to do like low price HIL where it's not break the bank HIL. Yeah.
Yeah. And that's what I'm going to show too, because there are manufacturers that they basically sell setups prepared for hardware in the loop, and they basically help you to do it. But usually they are quite expensive. And I have never tried them because they are like cheaper alternatives that probably they will get you there. It depends on what stage your project is. If you are going to, make sure that that millions of devices are working correctly, probably you don't want to go super cheap either. But for a first development stage, probably that's enough. Okay.
Have we beat this slide to death?
Yeah, exactly. I think this is more or less clear now. If it's not clear, also I didn't mention this, but feel free to contact me. Probably contact Joe too, if you want to continue discussing this, or if
for sure,
you guys think that we can help you with any of this stuff, let us know. Okay, and we are kind of finishing the presentation. My idea was not to go too deep, but to go very wide and to show what kind of things you can do with hardware in the loop. There are three main ways to use hardware in the loop. Two of them are very known. One of them is not so much known. And then I have something else at the end that I'm personally very excited about, because I spend 80-90% of my time developing embedded systems, and I think it could be really useful. So you will see it in a second. A lot of times you have HIL setups for development. So again, you don't want to test all your requirements on your hardware, and especially you don't want to test previous requirements of your hardware, right? Because in order to make sure that you didn't break anything, you need to actually test it on hardware. And there are basically two ways to do this. You either do it after each push or after each merge, which will be really painful, or you wait a while and then you test it like once every 6 months or once every month or whatever. Both have issues. The first one, basically you spend a lot of time. In the second one, it may be too late, because you may have include something that it's dangerous or that it doesn't comply with what you are doing, and you may find it too late on time, and that basically will take longer to figure out what's going on. So if you can push these tests into your infrastructure, that will be the best. And yeah, usually that's done connecting to the CI/CD and kind of automatizing all the testing into your hardware in the loop setup. Usually, I mean, if the project is really big, you are going to have a bank of setups, and depending on the availability, then you can test your system in one system at a time. Maybe you can divide the testing space into different systems in order to speed it up, and yeah, you can configure it according on your requirements.
Yeah.
Then the second one is on production. So it doesn't matter if you are receiving hardware or you are shipping hardware. You want to make sure that the hardware is doing what it's supposed to do and that your firmware is doing what it's supposed to do. So it's very common to have some kind of automatized testing. For example, in the incoming, you may receive some PCBs from countries that don't take too much care on how they manufacture things. So you will get your thousands of devices and you will test them one by one. Having an engineer doing that full time will be probably too expensive and too inefficient. So if you kind of automatize this, it will be much faster. And the same way goes outwards. If you have developed something before sending it to a client, and then the client complaining to you that it doesn't work and sending it back, and that's really expensive, you can test that everything is working correctly. That's also really useful, and you can do it in a chain, one device at a time.
Yeah, and a lot of people would call this manufacturing test too.
Yeah, exactly.
Probably heard that term.
Technically, it's a hardware in the loop setup, right? Because you are testing the hardware. Yep. In an automatized way.
And I think in a lot of cases, people can reuse a lot of the equipment that they've set up to do that hardware in the loop.
Yeah.
set
Totally.
testing. In some cases, that's fairly easy to do. In other cases, it's like, I don't know, bed of nails type of stuff, and then it maybe doesn't quite make sense. But there's a lot of value, I think, in that.
Yeah, and I think this is a good moment to say that this presentation, it's not only like things that I have personally seen. We have discussed a lot internally at D5 on hardware in the loop, and we have that a lot of we have put a lot of thought on how can we use it. A colleague of mine said that they, in a previous company, they were basically having a hardware in the loop setup for tech support. So if
we could go to
create
detail. I mean, not
something
all the detail, but I mean, again, this guy used to work at an elevator company. And so like a technician
exactly.
would like work, be out in the field at an elevator and say like, how do I fix this? I have no idea what's going on, right? I mean, that's the story you're talking about, right, Ander? Yeah,
exactly. I'm talking about that. So yeah, usually this doesn't work for very small systems, right? Because probably it will be cheaper just to deliver a new one. But for something as big as an elevator, for example, and that is safety critical, probably you want to like go there and fix it as soon as possible. And when the elevator is not working, it's like your example before, it's like the car is not working and what's going on here. So if you have hardware in the loop setup and you have thought about this beforehand, you can basically plug it in, then start doing tests, and maybe they will give you a hint on what's going on. And that will like allow the support team to like have a faster response, and probably will save you money too. So I think that this is a really cool way to use hardware in the loop too.
The other example we were talking about earlier was NASA. I think they're pretty famous for having like exact duplicates of the rovers that are, because like, going out to Mars, or you do a quick firmware update. Like I cannot imagine the level of pucker factor when you hit that, like, run the over-the-air update on the $1 billion rover out on Mars and cross your fingers that it doesn't screw up, right? I mean, in reality, what they do is they test it over and over again, and by the time that thing is actually over there, they're feeling pretty confident that they're never, even if they do have a bad firmware load, it's gonna. They have a recovery mechanism. They have a backup mechanism in place to handle it. So, but gosh, that's that's kind of the a very high stakes type of thing where my understanding is that they all of those tests, or even when they're considering different maneuvers, not even having to do with updates to software, but even just changing configurations, they test everything locally first before they run it out on the actual, or send the command out to run something out on the planet. So
probably sending a technician will be like too expensive for them.
Probably a little expensive, yeah.
but
might be a long lead time on that too.
Yeah. Okay. And then the last one, that this is something that I think will be super, super useful for developers, for embedded developers, that will be to have like local hardware in the loop setups, right? Because usually when we think about hardware in the loop, it's like a very high-end system that is placed somewhere like in a room in your company or in external facility that you cannot access. But I think now that hardware is getting cheaper and cheaper, we are starting to be able to have personal hardware in the loop setups, right? And if you are working with a team that it's remote, as it's my case, then it gets tricky sometimes to debug other people's setups, right? But if everyone has the same hardware in the loop setup locally, it will be much easier to like cross-test your systems, and there will be less issues with what I'm plugging where. And I think it will make like the development phase of the project more consistent. I think this is really cool, and I think that probably not yet, but we will see it soon in certain projects. Not all the projects can afford having hardware in the loop setups, but for certain projects where you can do it, I think this will be
because like if my product is an elevator, It could be tricky. Although then you might grab like copies. I mean, what I've seen a lot of times happen too is usually there's a run of like Rev A boards or something, right? That and they find a couple issues with it, and then they run a Rev B run, and so then there's all these Rev A boards. Like, and if you don't have to scrap them, and they work mostly like the older board, a lot of times you can salvage those and get those into developers' hands so that they can use those as HIL boards, and that usually is a good way to get hardware. But yeah, sometimes the hardware is just really expensive and tough to get. Yeah. And then I've seen, I think like you mentioned before, the like pooling. I mean, the grassroots, like poor man's way to do that is like you get a calendar on Google or Outlook or something, and you just say like, here's the calendar for this hardware. Anders scheduled from 8 to 2, and Joe's scheduled from 2 to 3. To use it, and then you kind of manage the resource that way. I think there are better options, but it's a great place to start. Honestly, it's pretty quick and dirty and works. So
yeah.
We had a couple questions.
Okay.
So Dave just mentioned to everybody they build the unit tests into the embedded app so they can be run on the hardware, and they also build the embedded app as a Win32 app to use it as simulated hardware, which is like a different spin on HIL. And I've seen both of those. Those both seem like pretty common practices. And thanks, Dave, for that. Yeah, and that's the interesting thing is, like, do you run unit tests locally on your dev machine, or do you run unit tests on the actual hardware? And I think there's pros and cons to that. Let's dig into that for a second.
Yeah. So I think that it depends on your setup. And I know that when a presenter is constantly saying it depends, it make it all really fast. But I mean, the embedded space is so big that having unique answers for all the possible projects, it's really difficult sometimes. I assume that in those setups they have some kind of abstraction from the hardware. I have seen that happening on embedded Linux projects where you don't need to worry too much about the actual interaction with the hardware, and then it's easier to do unit tests locally. If you are not, then it's more complex. It's doable still, but it's more complex because while you are testing, probably you are like interacting with the resources that the actual functionality is going to work with. So yeah, it gets tricky, and you need to be really careful. Usually, what I have seen is that on projects where they're basically bare metal, I have seen unit tests done in your development machine. Mm-hmm. So you don't actually run it on the system, but on your machine, because it makes it easier. And at the end of the day, unit test, if you are doing unit tests as unit tests, basically that means that you are taking a unit of your code and putting a wrapper around it and testing it. And it doesn't matter if you do it locally or not. If you want to test the interface with the hardware, then it gets trickier, because you cannot do that in your development machine. And you need to do it on hardware, but then again, you are interfacing with the resources of the machine. So yeah, it depends on the project.
And I would say too, I think if your goal should be this, there's a lot of research. Both Gansel and Grenning have harped on this for a while, but like the sooner you find a bug, from the moment you insert the bug into the project, there's like this time to detection that Grenning likes to talk about. James Grenning, if you guys aren't familiar, look him up. But it's this how long does it take me to detect that bug and then fix it? And the faster you can fix it, the cheaper it is for the whole project, and the less risk it is, whether it's financial risk or a schedule risk or whatever, right? So your goal should be to find the bugs as fast as you can after you put them in, right? That's all of our goals. Sometimes there are a million reasons why it's difficult to do that, and that's of course part of why the testing domain is very ripe for innovation. But
and that's.
Yeah, I mean, I was just going to say that things, I think it's one thing I'd see that I've seen in some cases is like, running the unit tests on the hardware is good if those tests are testing something about the hardware that's unique to the hardware,
exactly.
Because it still requires hardware, and there's still going to be like, oh, I can't find hardware today, or we ran out of X, or in today's world, like chip shortages, whatever, we couldn't build enough dev kits, or the dev kits aren't available or whatever, right? Like then unfortunately it ties you to that hardware. And so, as long as those tests, in my opinion, as long as those tests are like there's something unique or required about them, they have to run on hardware, then like, great, go for it. They are basically a HIL test. But if they're tests that you could be running on your dev machine, I think you're going to find that it's faster and cheaper and more scalable to run them, as like kind of unit tests. And I've seen, I guess, I'm not sure if this is Dave's situation, but I have seen situations where like that barrier to entry of like, how do I get started with unit test is what's holding that team back. They are, so I'm not saying this is you, Dave, I'm sure not, but if in some cases there are groups that they're just more familiar with how to run like something on the embedded like device than they are with like unit tests, host-based unit tests. And so that's a barrier to entry, and they just decide to do all of their unit testing on the actual hardware. And I think and there's pros and cons to that, but I think my recommendation would be write everything. Like unit tests are going to be the fastest that you can run them almost immediately after you type the code, and they run very fast if you write them well. And so you find out in minutes, maybe even seconds in some cases, that there was a bug. Yep, I need to fix it.
So I'm going to slightly disagree with something that you said.
Fine.
Yeah. And I may get in trouble here because you are the boss, but I want to make sure to clarify this. So you said that having unit tests in the system and running them is kind of a HIL. I don't completely agree with that. It's true that it has the hardware component, but is it really in the loop? Because what I have seen some teams do is basically have two versions of your firmware. One version is the firmware that you are going to release, and another version is the firmware that you are going to use to test. And they do different things, right? Because they basically run the test. You need to make sure that running the test on hardware doesn't interfere with the correct functionality of the device. So unless it's somehow in the loop, it's not technically.
You can get in trouble. You're saying you can get in trouble if it's a different flavor of what you're building.
Exactly.
If you're not careful, you can convince yourself that things are all A-okay when actually they're not. You've adjusted the thing.
And I feel pretty.
Go ahead.
Yeah. I feel pretty strongly about that because I made that mistake once and never again. So we spent so much time trying to figure out, because all the tests were working and then the device wasn't working. We're like, well, what's going on? And it was our tests that were interfering with the system. So that's why I don't feel really well when like we have unit tests inside the system, because sometimes if you do everything right, it may be okay, but sometimes you make mistakes and then it takes a really long time to figure out what's going on.
Those are the best kinds of learnings. Learned with, blood, so to speak. So the other point that David made was just about Win32 apps that use to simulate hardware. I've seen this, I've almost exclusively seen this used on devices that have a display of some kind. And so, and that is really valuable. Like a lot of times you're waiting for the display if you got custom LCD or something, it needs to be manufactured. You don't have a lot of them around, or you just have a lot of hardware built up. And so, maybe you're waiting for a touchscreen driver to be built or integrated or something like that. And so like you can't actually interact with the system. And so hardware is gating development and usually like getting the graphics library up and getting your elements on the screen and everything is something you want to do fairly early, because there's a lot to do on top of that. It's a foundational piece that you want to get in place. So I think that is another best practice I've seen, where people compile for their desktop machines, where they abstract out the display. And a lot of times you have to abstract out some of the simulation hardware. And maybe that's a good point to, one of the questions that we got ahead of time on our survey was about how would you test UAVs? And that is an interesting question. And when we talked about it a little bit ahead of time, it really was around like, well, I mean, you can't have this thing. I don't know, maybe somebody's got a cool like net, based system, but it probably can't actually be flying. I worked at John Deere. Brandon and I talked about that last time for quite a while. And we had the same thing. Like, I mean, you've got a whatever, like, I don't even know how many pounds, thousands and thousands of pound, ton. I don't know if it's thousands of tons, but, a very large piece of metal, like with a giant engine in it. And like, and we were doing GPS algorithms to auto steer it and stuff. And I mean, like, you can't test that in the lab. You can't test that Yeah, we had a test farm that people would eventually test it, but it was very expensive and the turnaround time was very long to get ship software out there, have people test it, ship it back the results. It was very human. It wasn't very automated. And so we had to abstract a lot of that, the actual wheels and the actual steering wheel and the actual CAN elements away to test that. And I think that's kind of what Dave's even suggesting here too, is when you've got a user interface that you need to abstract away for some reason, you can do a lot with that. It is a really good way to do it.
I think that I have been really unlucky with that too, because usually all the projects that I have worked on, they were using fairly new hardware that you could not simulate. And sometimes when we try to simulate it, we were I used to work on really low level stuff, low level on the really close to the hardware. And then I always found bugs left and right, because maybe the high level implementation was right, but the low level simulation was not so good. So in my experience, it depends on what you want to do. But usually in my experience, it's really difficult to find a really good simulator, depending on the architecture that you are using and on the hardware that you are using.
Sure. Yeah. Although I think some of the libraries are starting to get to that place too, where they will not only ship the embedded code, but they also ship code that builds for Win32, so that you don't even have to, if you take an off the shelf library. One other question Venkat just mentioned, hey, sometimes there's a runtime bug that occurs very, very rarely, and it's humanly impossible to run them on unit tests. And I've got a good story around this. When I was working back at Deere, there was a really, really nefarious bug. We got a report back from and it ties into HIL really well. There was a bug back from the field. So this was our test farm, right? And there was I think we had 100 units built up at the time. And there was a guy that said on this particular unit, unit number 75, every once in a while, once every 10 minutes, the screen goes to static just for a flip second, and then it comes back. And that was the only, and I'm like, what do I do with this? I don't even know. Luckily he had figured out that it was only that unit and not other units too. But I brought it to my desk. I was playing with it. I'm like, I don't know how to make this happen. And luckily I had some good mentors in front of me and that were helping me. And one of the hardware guys really loved freeze spray. And basically we initially figuring this out, he was able to kind of freeze spray around on the device. And once we knew it was one device, we knew there's some hardware element to it, right? The other devices don't demonstrate it. But we were able to freeze spray around, and eventually found that if we freeze sprayed the memory, the DDR that was on there, it would happen slightly more. But still not that often. And you're just like, okay, what does that mean? And then they went, when you design in DDR into a project, there's all kinds of timing things that can be wrong. It's typically what you'd look for on hardware. But of course we had these other 99 devices that weren't exhibiting this. And oh man, that was but the way we pulled in HIL then is because we talked to the manufacturer of the DDR chip, because eventually we did some bare metal testing. They were not interested in helping us at all, because we weren't at quantities where they cared yet. And it kind of said, well, it's a DDR. You're probably using it wrong. Go figure it out. So we had to prove it to them. And there was we had to do basically we were able to build a HIL around this device that we could constantly cycle it through. And we had to actually pull out the OS. We had to run down a bare metal running memory burst tests in a cold chamber down at -40, bring the whole board down to -40, run these tests. And eventually we got it to fail in a way where we could actually say hey, look, your memory is failing. And it turned out they had a marginal issue at -40 on only certain on some DDR chips falling out of the factory. So it was just kind of, again, a place where a HIL infrastructure that's the type of thing you have to test on HIL, right? You're not going to be able to test that in a unit test, and it's because it's hardware related issue. So I think that's
my worst bug also it's related to a manufacturer, right? Because you assume that they have done their job correctly, and then you assume that it's your fault, and then you start testing absolutely everything on your system.
Yeah.
And it will be much faster if you could automatize the like checking on the hardware. And we didn't have that at the time, so it took us like 2 months to figure out what was going on. It was a security issue on one chip. I'm not gonna say the manufacturer.
No worries. All right, let's move on. We got about 10 minutes left, so yeah.
So maybe you want to take this.
Yeah. Well, I mean, and just kind of to talk about the different types of hardware in the loop, like, I mean, at D5, I don't think it's a secret. We've got EmbedOps. That's our kind of automation piece, and what we're putting in right now, this quarter, we're building in some big features around hardware in the loop. Our vision for hardware in the loop, it really kind of dovetails from a lot, I think, of what people have done. But as a general architecture, I think that a lot of people could use in general. Like, so we've got our EmbedOps cloud, which has test templates. And actually this dovetails into, Bob had a question about what are your favorite tools and languages for writing HIL tests and for executing them, collecting run results. What I've consistently seen, and I'll give you a sec here, Ander, to say too, but what I've consistently seen teams naturally gravitate towards is a Python executor running on a HIL host, talking over, usually over some sort of serial port for the majority of the tests, but then sometimes you have custom GPIO, and there are Python modules that will talk to National Instruments equipment or general GPIO kind of stuff. So that seems to be where people naturally gravitate. And that's why, like, our test templates are all based on PyTest and Python environment. Generating the pipeline, being able to visualize the test, updates, maintenance. I mean, that's stuff that we kind of build into our EmbedOps stuff generally. But then in the hardware and the loop side of things, there's always a HIL host of some kind, whether that's a little tiny single board computer. I know you're going to get to that, or whether it's a desktop PC. A lot of times you see that too. A lot of times the National Instruments stuff is involved, and that's why it's all on there. But something with PyTest, a host CLI, something you can drive the host with, sometimes of fixtures, and then some type of protocol that's getting transported. A lot of times, like I mentioned, we see UART or serial being the transport, and some other external interfaces. And then over on the right, for the device under test, there's some kind of library that can accept those hardware in the loop changes. I think the best thing we've seen, though, is that it's really valuable to just have a CLI of some kind on your device. And if you can use that CLI not only to do some kind of high level testing, but also some low level testing, I think that there's just a lot of value in kind of one-off tests, as well as helping you drive automated tests.
Yeah, I'm gonna be really fast. What I have seen is either PyTest or GTest, basically, and then communication with the board with some interface that you are not gonna use in production. So whenever, or on deployment, so whenever you are deploying it, you don't want to test on the same interface that you are going to use to communicate with the device. So some serial port that you are not gonna use in order to communicate with the device, and then from there you can test either Bluetooth, Wi-Fi, CAN, whatever you want.
Yeah. And go out to our website if you got any more questions about this or have some interest in this, because we're actively working on this now. So
or feel free to send us an email or contact on LinkedIn or whatever.
Yeah, great.
Okay. So now, in order to finish this, we received some questions before the webinar, and I wanted to go through the answers. I think that most of them have been answered by now, but I want to make sure that you get some value from this. So the first question is where to start, right? I want to start with hardware in the loop. We don't exactly know how to do it. We have thought about, so these guys are saying having some kind of checking the version with UART or whatever. So
I really like that. Just a boot test, just a smoke test is what I would call it. Does it boot? Yeah, that's something you can't, that's a value you can't get from unit tests easily, very easily at all. And it gives you some level of confidence that that you're starting. So I think that's a great first place to start. Just get a serial port or something, dumping a version string, check from PyTest.
Yeah.
And that, go ahead.
Probably, so I have seen minimal versions done from the development machine. But the main issue with development machines is that they don't usually have too many GPIOs, so external ports. And what I have seen consistently is having some like a small board, like a Raspberry Pi usually. Then you can connect to it either through the cloud if you want to connect it to your CI/CD system or from your development machine, and then some kind of program basically listening on the Raspberry Pi, and then whenever you send the Raspberry Pi the firmware, booting the firmware and sending a message or receiving a message, something like that. At a minimum, you probably want to like load your code or your firmware from the hardware in the loop machine. That way it allows you to like test different versions and then communicating it somehow. And usually it's technically not minimal, but usually you also want to control the power on the device under test. So if you can turn it off and turn it on again, and that way you make sure that a particular test doesn't interfere with another one. And I think this is the minimum that you can go with.
That's kind of a
minimum,
really base level.
Technically it will be more minimum if you forget about the AC or DC power control and you use your development machine instead of a Raspberry Pi. But I think that this is small enough to be considered minimum.
Real quick on this one.
Okay, super fast. We had an electrical engineer asking like how to make, like what decisions can we take early on in order to make sure that how in the loop is easier to implement later on. Okay. And here I want to talk about Flipper Zero. I think this is a really cool machine. It's open source and they are very, very open on the manufacturing system too. And the lesson to learn here is if you know that you are going to have some hardware in the loop requirement, the earlier you know it and the earlier you plan for it, the better. Probably you want to have some testing points on your hardware that will make it much, much easier to test later on. Probably you want to make sure that at least one interface is used just for debugging. It could be serial, it could be something else, but it's usually serial because it doesn't require too many GPIOs. You want to make sure that you know what interfaces are going to be used in which stage of the process. And what these guys are doing here is basically they have a hardware in the loop setup in order to test the receive boards. And you can go to the blog post. I think it's really interesting. And they explain to you very in detail how they do all the testing on receive devices. I think it's really cool.
Very cool. And I mean, internally, there's people said like, make sure you got exclusive debug port, could be RTT or could be, some other like trace level thing, or it could be a serial port, right? Lots of test points.
There was something about if your processor allows tracing, like try to take advantage of that. And that means allowing the hardware, like allowing to access the trace pins from the hardware. So if you can take that into account too, that's interesting. And this is the question about the unmanned aerial vehicles.
We answered that already, I think.
I think. And that's it. Next week we are going to have this is not next week. This is August 25. Okay.
Yes.
We are going to have another webinar on how to work with Jenkins, right?
Yes, that's right. I'm just laughing at the title again. Free, fast, and foolish.
I think it's really interesting to have this series of webinars in order to like bring back a little bit to the community. Mm-hmm. So I think that's everything.
Michael had one extra. We got one more minute, so maybe we can answer it real quickly. But the one question that's outstanding still is, what stage of development would you recommend testing or setting up HIL?
At the very beginning, the earlier.
As soon as you have hardware, right? You can't set it up before hardware, but
but you can think about it. You can think about it before hardware.
So design for it.
Exactly. The earlier it comes to your mind, the better. If you know that you're gonna need it. Because usually when you do it like mid-project, it's like it takes more time to set up and it takes more resources to make it work.
Perfect. All right. Thank you, everybody, for joining us. This was awesome. Thanks, Ander, for putting this together.
Sure.
And yeah, as we mentioned, if you have any other questions about HIL and EmbedOps or anything from Dojo 5, let us know. Feel free to reach out. Thanks.